In this video, we're going to take a look at Chapter 5, problem number 36. The problem reads, the temperature of 2.5 liters of a gas initially at STP is increased to 250 degrees Celsius at constant volume. Calculate the final pressure of the gas in ATM. So, first off, what's STP? Alright, STP is standard temperature pressure, I'm pretty sure. But the key thing you need to know is 273 degrees Kelvin. Oh, it's referring to like the state of the matter. So 273 degrees Kelvin, or 0 degrees Celsius. And that's temperature, and then pressure is 1 atmosphere. Alright? That's what they mean when they say STP. Okay? Don't worry. Now let's write out our ideal gas law. So we have PV equals nRT. Alright? And so let's see. The thing is for this one is we have two stages. We have an initial and a final. So let's call stage 1 and stage 2. Alright? And so at stage 1, our P1 is that it's STP. So that's that 1 atmosphere. Alright, so 1 ATM. Alright, our V1 is 2.5 liters. The 2.5 liters, that says. Our N1 is, we don't know. And our T1 is 273 degrees Kelvin. Don't do Celsius, okay? Alright, now let's look at stage 2. Our P2, our V2, our N2, and our T2. Now it says it's increased to 250 degrees Celsius, so we do 250 plus 273, and that gives us 523 degrees Kelvin. Alright? Now let's look. Pressure is what we're trying to find, so question mark there, and then volume is, it says, at constant volume. So the volume stays the same at 2.5 liters. Now this is the key part of the problem. We don't know what that moles of N is. How are we going to figure out? We have two unknowns here. What are we supposed to do? Don't worry. We basically say ignore stage 2 for now, so cross that out. Let's only focus on stage 1. We have all these variables here. Let's solve for the moles of gas. We can do that. So we take these values and plug them into the ideal gas law. Alright? So what is pressure? So PV equals nRT. Pressure is 1 ATM. Volume is 2.5. N is N. R is our 0.0821. And can I fit this in here? T is 273. That's a bad writing. Alright. And then we basically just solve for N. Alright, so divide the 0.0821 and the 273. Sorry, this is a little squeezed in there. And here it's the same thing, okay? I can't fit that there, alright? And we basically solve for N, and that gives us 0.11 moles. Alright? So now we know that our value here for N1, we know that is 0.11 moles. Alright? Now if we look back at the problem, it doesn't say anything about changing moles, and it doesn't talk about any extra gas, so we know that this number of moles stays the same. So in N2 we can write 0.11 moles. Alright? Then we look at stage 2 now, and realize, hey, look at that. We have three knowns and only one unknown. We can set up another ideal gas law, and we basically can solve for that final pressure. So we write that PV equals nRT, P2 is our variable, V is our volume, which is 2.5 liters, N is 0.11, which we solve for, R is 0.0821, and then temperature is 523 Kelvin. Remember, it says to 250 degrees Celsius, add 273 to that, alright? We then just simply divide by 2.5, and that leaves us with P2 equals 1.9 atmospheres. And that's our final answer. Good job.